Now in exercise 2b, we will apply gradient boosting, and this time we can also use the regression. Install the package if you haven't already, and then import it. So GBM stands for Gradient Boosting Machine. Next, we will use test train splitting for our regression data. And we can build this simple model here, which is a gradient boosting machine that uses 200 trees, and we will use tenfold cross-validation here as well. So this might take a few seconds, and we get some valuable informations. So for example, here the of the 30 predictors, for example, 23 had a non-zero influence, so basically 7 predictors were basically unimportant, and the cross-validation shows that or the best cross-validation iteration was at 107, so we could actually reduce the number of trees. Then let's see the summary of the model. Here we get the relative information, the relative influence of the single predictors. So this is a importance measurement, and here you can see that this y-axis is actually not that accurate, but we can see the exact values here for all the variables. Then next, let's get the predictions of this model. So here I actually have to define the type as the response, and we can now calculate the RMSE. So here this is the test RMSE, and this is the train RMSE, and of course we see that the train RMSE is smaller than the test RMSE. Now we can do the same for classification. So build our model, and we set the distribution to multinomial, so it won't assume Gaussian. And we can again print the summary. Shows us the influence of the relative influence of each predictor. Then we'll get the out of sample predictions. Which I have to encode a little bit, otherwise we won't be able to calculate our metrics as we need it. So if I now print these results, we can actually see that now we have the our test y values, which are the actual values, and the labels from the predictions in the form that we needed. So in the classes for all the observations, which would not be the case if we actually wouldn't apply this transformation here. Then we can calculate the classification error metric out of sample, and we see that it is even a little worse than the AdaBoost classification error that we calculated before. So here this might be due to overfitting, for example. We didn't apply any regularization, so this could very well be